Good afternoon and a warm welcome to my fellow KZN Centre Committee members, officials, and members of the South African Institute of Electrical Engineers and guests. My name is Jay Kalichuran. I'm the outgoing chairperson of the KZN Centre of the South African Institute of Electrical Engineers. I hope you are all taking care and keeping safe during this pandemic. A few webinar rules. Ensure that the volume is turned up on your device. Ensure that you have a stable internet connection for smooth streaming and audio. You can ask questions via the questions panel, which is located within the GoToWebinar control panel. By default, the control panel is located on the right-hand side of your screen. If we do run out of time, your questions will be answered and posted on the website. You will not be able to chat with each other. However, you are encouraged to ask questions. A recording of the presentation will be made available on the SAIEE YouTube channel, which is SAIEE TV. The recording will also be made available on the SAIEE website under the Events drop-down menu in the section Past Events and Webinars. This page is updated regularly. Visit often for new uploads and subscribe to our YouTube channel. A certificate of attendance will be issued a few weeks after this webinar once we have received the CPT validation number for this webinar. Our future business. We have our chairperson's breakfast meeting, which is scheduled for the 20th of April, which will be in the webinar format. And there are two topics. The first one is a 12-month field trial of novel conductor coatings for increased ampacity and performance at UKZN. And the second one is a brief history of power line robot development and detail on most recent advancements. Center presentations are held monthly between February and November, and these will continue in webinar formats. That brings me to our annual report for 2020. The focus of the second year of my term of office as the SAIEE KZN Centre Chairman was to serve the local membership by sourcing papers of interest to be presented in KZN in both Durban and Pietermaritzburg between February and November, and to host CPD courses in Durban. The year started well, with February monthly events held successfully in both Durban and Pietermaritzburg. However, all plans and good intentions went awry with the onslaught of COVID-19 and the subsequent lockdown in March 2020. The year proved to be difficult and challenging, but the committee continued with its operations. Administration tasks were fulfilled, committee meetings were held online, committee members were updated via email, portfolio tasks were placed on hold, and in-person events were restricted. Monthly presentations were replaced with webinars, hosted by the KZN Centre and supported by the SAIEE head office on their webinar platform. A big thank you to the head office webinar team, especially Mike Barker and Minx Everbros for their assistance. The proposed CPD program by the Centre was postponed due to COVID restrictions. Head office did arrange a few online CPD courses. However, these were not very well attended. COVID provided some technology changes and networking. I attended monthly SAIEE online meetings with Centre chairpersons, which was chaired by Roger Cormack. This was an excellent forum for sharing of thoughts and ideas. We had a few online courses which are on a list, and it is it will be shared. Committee members signed non-disclosure agreements, which were submitted to the head office, and this is in line with keeping confidentiality. The South African Institute of Electrical Engineers also embarked on a work-integrated learning program. 19 students from the Durban University of Technology and Mangosuthu University of Technology completed and submitted their applications for consideration. A 2021 planning meeting was held in December 2020 to plan activities for the year ahead. The center has sustained itself over the year and has some fair funds left in its coffers. To be exact, we have 135,976 rands in the bank account as of February 2021. The 2020 committee members were as follows: myself, Jay Kalichuran, as the chairperson, Shepard Nkosi as the vice chairman, Zola Shangaze as our immediate past chair. We've had TC Madikane, Chris Rambo, V. Ramnarayan, Cyril Rutters, and Rob Stevens as our past chairpersons. We've had Richard Ashlaga, Crystal Anamale, Mohammed Isab, Mokapa Lekanyane, Kanchan Maraj, and Nishal Premlao as our elected members. We've had Tandi Sishi, who was a co-opted member on the committee, and Gillian Nautier was our secretary. I would like to thank eThekwini Electricity for providing the venue for the Durban presentations, and Eskom for providing the venue for the Pietermaritzburg presentations. The KZN committee members for their support and assistance in running the center successfully. I could not have asked for a better team. Their ongoing interest, time, and input has proved invaluable, especially during 2020, which was such a challenging year for all of us. I'd also like to thank the presenters who responded to our call during the year, and our secretary, Jill Nautier, who's done an outstanding job in coordinating the events and ensuring that all admin tasks were timeously completed. And as I end this chapter, let me convey my congratulations to Shepard Nkosi, the incoming chairperson, and Richard Ashlaga, the incoming vice chairperson, and I wish them well for their term of office. I have confidence in their leadership in the KZN committee. Thank you, and that is the end of my report. It also gives me great pleasure to announce the new committee for 2021. Our new chairperson is Shepard Nkosi, our vice chairperson Richard Ashlaga. The immediate past chairperson will be myself, Jay Kalichuran. The 5 past chairpersons would be TC Madikane, Chris Rambo, V. Ramnarayan, Cyril Rutters, and Rob Stevens. The 6 elected members, Crystal Anamale, Mohammed Isab, Makwapa Lekanyane, Kanchan Maraj, Nishal Pranlao, and Tandi Sishi. We have 2 places for co-opted members, and as if that does happen, we will co-opt them. Our secretary is still going to remain as Jill Nautier. Let me take this opportunity to congratulate all of you, and I wish you well. Just a note, the handouts pertaining to the AGM are posted on the webinar, and you're most welcome to download them. I now present to you our incoming chairperson, Shepard Nkosi. Shepard Nkosi is a South African male living in KwaZulu Natal. He holds a Bachelor of Technology degree in Electrical Engineering. He holds a post degree with the University of Southern Queensland and another post degree in Project Management with the University of Stellenbosch. He is currently completing his MSc with the UKZN, and he is professionally registered with EXA. Shepard is now the chairperson of the South African Institute of Electrical Engineers. He has served as the vice president of the Durban University of Technology's advisory board. Shepard is employed by Transnet as the senior national manager in the engineering department. He is the National Strategy Development and Implementation Specialist. He carries an extensive portfolio of successfully developing, executing, redefining of business and operational processes and services for the attainment of overall organizational efficiency. He has a diversified industry expertise and has been in a senior executive position such as shareholder, director, general manager, head of department in industries such as manufacturing, petrochemical, electrical, engineering, and property building, and coaching successful cross-functional teams, directing the implementation of business energy, fleets, facilities, green building designs, and maintenance. He has been in the built environment sector involved in engineering designs, energy-friendly building services, power stations, LV electrification, commercial complexes, shopping malls, residential and government complexes, and is dealt with development projects valued at between $500,000 to $5 billion. Mr. Chairperson, your badge will be delivered to you in due course. And in keeping with tradition, it is now for me to leave you in the hands of our chairperson, Shepard Nkosi, who will give us the chairperson's inaugural address. Shepard, over through to you.
Thank you. Thank you, Jay. Thank you so much for the introduction. If I knew that this introduction was coming to this place, I was going to give you the shortest one. Can you hear me? Sorry, Jay. Can everyone hear me? Okay. No, perfect. Let me check with you, Jay. Am I audible? Can you hear me?
We can hear you, Shepard.
Oh, perfect. Thank you. Thank you. Let me just share my screen here quickly, and I will be ready. Let's see, I've lost the share, but let's go back and share. And while I'm doing that, I would like to take this opportunity and thank you, Jay. It is an honor and a privilege to actually take over from you. I must say, you've set the bar very high, and looking after the KZN region, the SAIEE during the COVID pandemic and the restrictions that we had in the past 12 or 24 months, it is really an honor to take after you. And I think there's a lot that we've also learned from you. And you were innovative, I must say, in terms of some of the courses that we usually enjoy, or training that we usually enjoy as engineers every year. Last year and the last 12 months was not easy, but you were innovative, and we've managed to attend few webinars and managed to also get new members to join in the SAIEE discussions. And we've actually managed to also deliver on the business mandate despite the pandemic challenges and few other issues that we were faced with. And thank you so much for steering the committee in the right direction. And it is an honor and a privilege again to take over from you. I just want to check if you can see my screen here.
We can see your screen. Just put it into presentation mode, Chef.
Okay, perfect. Let me then minimize the box here. Then we're ready to go. Okay. No, perfect. Let's go straight to the presentation. So what we would like to discuss this afternoon is energy and sustainability. What does it mean to you and I as engineers? And you will agree with me that when we talk of energy as engineers, energy is simply defined as the ability to do work. Energy is how things change and move. It takes energy for us. I think we all know that to cook, it requires energy for us to move our vehicles, and for us to even jump up and down, it requires energy. And on the other side, the sustainability part, it is broadly defined as meeting the needs of the present generation without compromising the ability of the future generations to meet their own needs. And collectively, we can see the responsibility that's given to us as engineers, and especially since we face with these environmental issues, climate issues, food shortage, and the list is long. And both the energy and the sustainability components or definition as we've shared, they link very closely to our society, to the economy, and they also are linked to the climate change. It is in our hands to change some of the mistakes that were done in the past in terms of the design, in terms of how we looked into the energy space, and also to sustain what we have in order to save this planet for our future generation. And surely the sustainability, if we dwell into the sustainability space, it covers three main dividends, which is the environment, the economy, as well as society. So these are the three key drivers of sustainability. And within the engineering built environment, you will agree with me that we cannot separate these functions. You cannot separate the environmental issues, the economic, as well as the social challenges that we face with them. Most of the projects that we are tasked to deliver as engineers, they are addressing these three components. And if we neglect any of these three dividends, the obvious answer is that we might not have business tomorrow, and maybe we might not even have a room like this where we sit as engineers and discuss matters that has to do with the engineering space. I would like to dwell for a few minutes our discussion on the energy cost as we are touching on energy and sustainability. The first part of our presentation will be on the energy space, in the energy space. The South African environment has been experiencing electricity increases, and it was actually unbelievable what has been happening in the past few years. South Africa has inflated by a high percentage in the last decade, and this is obviously linked to our main supplier, which is Eskom, struggling with now chronic load shedding issues and capacity expansion that we all are aware of. And this does not only affect private sector, even the state-owned companies are affected by these changes. And as we also contribute approximately close to 20% of our operational cost, it's the energy cost, we are also affected collectively, and the society at large. And you will also agree with me that in South Africa, the South African grid network, it's actually 72% of it is coming from coal. And the electricity generated, if we look at the projection, you will see exactly how it is performing and how it is leading to some of the challenges that we are faced with as we're going to discuss this. The energy sector in South Africa contributes approximately 80% of the total carbon emission. 80% of our emission is coming from the energy sector. And the latest integrated resources plan, the 2019 one, it advocates more renewable energy from 2020 to 2030 to try and reverse some of the damages that we are currently experiencing as a result of carbon emission and other inefficient systems that we might be faced with or having to maintain. So this is the biggest issue that we are faced with as a South African, and it's not only a South African issue, the issue of emission, carbon emission, and the contributors being coal, and then in other areas, transportation, and also in our space, it's exactly the same, the trucks, buses, everything contributes, and the energy sector, it contributes about 80% of our carbon emission. But the 2020 to 2030 plan, the IRP plans to introduce renewable energy. Let's look at why is this important? What are some of the challenges that we are currently faced with? And why do we say as engineers, we need to collectively come together and work as a team in resolving this issue? The electricity tariffs are expected to continue to increase at about 12% per annum, as shown in the figure. And while this presentation was prepared, you will also agree with me that just early this year, Eskom has announced an increase in our electricity tariff of, I think it's averaging about 15.6% increase. So we can already see that in terms of the average tariff increase, it is way above the 15%. And the average tariff increase bar, which is estimated at about 11%, we already above that, the 12% that we even estimating. It's more conservative if we look at the increases that we are currently expecting. And this was a study that was done in 2020 by ABSA. And surely some of these increases, as much as yes, Eskom can declare 15.6 average percent increase, if you get to the municipal level, some of the private sector development, the percentage will be even slightly more. And mid-2021, we'll see the effect of these price increase. But on the other side, the graph that we are projecting now, it indicates the fast falling prices of the renewable technology, the PV, the wind, CSP, and we can see really the percentage reduction. PV has dropped by about 83% from the time we started talking PVC 2011 to going forward. If we look at the CSP, also about 65% reduction, and this is something that's ongoing, and it is getting reduced as the technology is advancing. And what does this mean to us as engineers? We need to take ownership of this space, and we need to embrace this technology. And this will start from as a design as simple as a residential area. And there are options that we can always consider when developing a residential complex, residential flats, houses, duplexes, any type of development that we might be thinking of. The obvious thing that we can see here, this price reduction confirms one thing, that our return on investment has improved as well. There's now buy-in from the investors and the developers if we advocate of this renewable technology as design engineers. And the focus, obviously, it's not only, these issues are not only in South Africa, as much as we are dwelling mainly in the South African energy security issues, but you will also agree with me that some of these challenges are common in other countries, our continent, as well as European and Asian countries. We are more or less going through similar challenges in terms of the emission. But one thing that we need to also look at is the development that's coming from these developed countries versus where we are. And that will also give us a dipstick of how much work we need to do in order to make sure that we catch up and we own the space as engineers who are given the authority to guide the society. The South African energy security has been experiencing capacity constraint since 2007, and beginning 2008. You'll agree with me that the chronic rotation load shedding to avoid the grid collapse was something that was introduced, and it was a good move from Eskom to do that. Surely none of us in the room will be happy if we went through the grid collapse, and it will be costly, and it will take weeks for us to get back to a system that's healthy and up and running. And the grid has been constrained as a result of capacity shortages, with the reserves margin declining to below the acceptable 15%. And to actually even populate some of the issues that Eskom is experiencing, the Eskom power plant energy availability factor, which they use the EAF, has been declining drastically since when we've been experiencing this load shedding, and it has been declining below 60%, and that has also been experienced in during 2019. That was noted at 60%. And why do we indicate the EAF, and what is this? What does this has to do with us as engineers, electrical engineers and design engineers, electronic, mechanical, system engineers? The EAF is a percentage of maximum energy generation that a plant is capable of supplying to the electrical grid, and limited only by the planned and unplanned outages. And with Eskom, the system adequacy outlook, Eskom indicated that Eskom system adequate EAF is expected to be above 70%, and that's when they deem the system to be healthy. And based on their assumption, Eskom predicts that the load shedding will not be something of the past. We'll still be going through the load shedding, and that on its own confirms that our EAF is below the targeted percentage. And as you can see here from what was projected or displayed in 2019, the percentage is getting lower and lower. And that just confirms one thing, that we might be experiencing this load shedding in the next 3 to 5 years. And the question again that we'd like to ask is, who should address this issue? Who should reverse this issue? We as engineers can contribute and fight the battle with our local municipalities, with our private developers, with the state-owned enterprises, with the government, with Eskom, in making sure that the picture that we see improves. If we look at the energy landscape, the energy system is fragmented, and but one thing that we want to highlight here is the two increasingly visible features of the energy system: the ability to shape the market, and the other one, the increasingly volatile market environment. And in the recent past, energy market has been dominated by large players whose scale has been a deep source of advantage. But the picture is slightly changing now. And the advancements that we've seen in the technology, the distributed generation, the renewable technology, it is in our hands to change the space. And Eskom has also come into the party with the government to say they are supporting the renewable technology. So it's no longer a space where it is the market, it's only controlled and managed by one or two big players. And we can start by introducing some of this technology in our very small design. And if we are the advocate of this change, from when we get the invitation to from the developers to say, we've got this shopping mall that we like to design, you to be involved in, we've got this residential area, we've got this type of project. If we start from that space to control and manage changes going forward, to say, as an engineer, I shall only get involved if this type of technology is supported, or this type of approach is supported in support of the energy efficiency as well as the sustainable developmental goals. And you will see really that we do have the capability of South Africa. The PV power potential, looking at the global horizontal irradiation within our South African space, we've got close to 2,500 hours of sunshine annually. And we're averaging between 4.2 and 6.5 kilowatt hour per square meter within a single day of available energy that we can harvest from the sun. And surely, as engineers in South Africa, we have no excuse not to embrace this technology. If you look at the South African regions and against other European and USA, in South Africa, the annual 24-hour solar average, sorry, there's a message that just came in here. All right, I've switched it off. The global solar radiation average is about 220 watts per square meter for the South African environment. While if you look at the USA, it is about 150 watts per square meter. And part of USA, it's about 100 watt per square meter. So we can really see that as South Africans, the ball is in our court. We can actually influence this PV technology wherever it's practical and possible and feasible as engineers. And this was a study done in Durban for the Durban space. Annual average radiation, as you can see from the graph, it's averaging at about 4.51 kilowatt per hour per square meter per day. And looking at the month January being the highest month, and also around about October, November, December, but even during the winter period, we're still above the expected kilowatt hour per square meter radiation. And it makes our PV technology viable in our spaces. And you know, we didn't even include areas like Uppington and other areas that will actually double up some of these figures that we see here. And also looking at the temperatures, still looking at the renewable possibilities. KZN Durban in particular, we've looked at the average temperatures in Durban in particular, and you know, it average throughout the year, it averages between 15 and 39 degrees Celsius, and down in Richards Bay, and it's even more there. You can see that you know, they even averaging slightly higher than the Durban space. So again, this just re-emphasize the obvious answer that for us, there's no excuse not to embrace some of these technology. And I think this slide is also just re-emphasizing what we've just covered. And looking at the wind generator or wind generation plans, is this a possibility? Yes, it is a possibility. And looking at the KZN space, and if you go up PE, East London, the picture is even much better than what we are presenting here. But just for a study, the wind generation potential simulation was done for the Durban space. And you can see here that the month of January, as well as October, August, September, October, you'll get the highest wind speed. And if we look at one of the suppliers of the wind turbine, starting from 4
Shepard, you seem to have got onto mute. We couldn't hear you just after. You could just go back.
inland can be.
There we go.
Oh yeah. Sorry, Jay. I'm still audible. Can you hear me? I think there was an. Can you hear me, Rob?
Yeah,
Yes, we can hear you. Just take that slide again.
Okay. Can you see my slide?
Yes, we can. If you just go through to the wind slide again,
yes.
We missed most of that.
Oh, great. No, perfect. So what I was covering from this wind slide was the fact that, in KZN, as much as one can argue and say, in terms of the average wind speed, Durban is a bit low, but the simulation and the studies from the meters that are installed, they confirm the opposite of that. There's also possibility of us harvesting wind and introducing the wind technology in the KZN space. And looking at the graph that I'm presenting here, it's a live simulation and it's coming from information that was collected from site. And from January to December, one can really see that there's possibility of wind technology, obviously depending on the size of your turbine. But wind can also be a solution that can be combined with other technology, if possible, when we consider some design. And the distributed generation potential, again, in the Durban space, this is a simulation based on a live site. And one thing that I can confirm, just the 3 months, looking at the combination of the wind power, the wind technology, PV solar, and a battery storage system. Looking at the first graph, the January graph, one can see there that, there's potential, one can harvest wind as early as 6 o'clock in the morning and going all the way down to about 9 o'clock. There's high wind speeds that can be harvested, and this is an average monthly peak that was collected throughout the month. And looking at PV solar as well, 6 o'clock, and your peak is about 1 o'clock, and then it drops down at about 6 o'clock. So there's a possible PV, wind, as well as a combination of battery storage, and that will reduce pressure to Eskom and to our local supply authority which is in our case, it's a eThekwini. And looking at the different months, Feb and March, we can see really that there's a bit of technology, renewable that can be harvested depending on the technology that one is proposing. And that can really reduce the pressure, and especially our peak demand. We can then shift our demand or reduce the peak demand, and that will obviously reduce pressure to the network and to our supply authority. Another technology that's within our control, and the design of the infrastructure is in the hands of the electrical engineers, is the electric vehicles. Like it or not, the electric vehicles are with us, and this EV technology is moving at a very high pace. Mercedes-Benz have confirmed that close to what's the percentage? I think firstly they've injected about 70 billion euro on making sure that their plants, the technology is up to speed with the preparation of the electric vehicles. And they are looking at 2030 as the benchmark, where close to half of their fleets that they produce will be purely electric cars, and to get rid of all other combustion engines. And Volvo on the other side is pushing the very same technology. But one thing that's very interesting with Volvo, they're looking at 2022 to start introducing zero emission truck, the industrial heavy vehicle trucks. And I'm talking electric trucks. And one thing that's quite interesting with this technology is that the very same infrastructure to support these, to embrace this technology, is designed by the electrical engineers. So again, it's another space that we don't want to neglect as we talk of the energy and sustainability. And as we talk of embracing the sustainable developmental outcome, we want to always remember that there's the electric vehicles, there's the good and the bad part of it. Obviously, even if one can dwell on the bad part of it, the obvious thing is that technology is evolving. The fourth industrial revolution, it's something that we cannot reverse. So 10 years down the line now, half of our fleet will be electric vehicles. And the plan is that by 2040, none of the fleet that we have on the roads should be the combustion engine. Will all be on electric vehicles. And just high level, the electric vehicles, what does that mean to me as a designer, as an electrical engineer? You know, if you look at the charging points for these electric vehicles, if you look at your SUV and your small sedan cars, let's take maybe a conservative one engine, 150 kilowatt electric SUV will take max about 260 minutes on average to charge. And you look at your EV car, your 50 kilowatt sedan will also take about 260 minutes on average to charge to 70%, and the EV, the SUV, it's to 30%, depending obviously on your battery life. And if one had to design the charging point, you can see there that some of the studies that were done, they indicate that the demand for a number of chargers that can take 4 cars, if we use the spec below, and the day-to-day variability in visiting frequency sitting at about 10%, and the session duration variability sitting at 30%, you're looking at a kilowatt demand early in the morning, and the peak being early in the morning at about 8 o'clock, 7 o'clock, 8 o'clock. That's the peak where your demand will sit at about 3, and then also averaging dropping down late in the afternoon. And this is also based on the current setup where we know that people who drive early in the morning, they park their cars, they go to work, and that's when then they will need to charge. And then if you look at the 2.5 hour charge, 260 minutes, sorry, you can see that if you park your car there, then in 260 minutes, then the demand will be low a bit. But what does this mean to you and me, to you and I? It means that we slowly need to embrace this in our design. If I'm doing a design of a shopping mall, these are the things that we need to start embracing in our design. If it's a residential complex, we need to start influencing the future projects that are planned for the next 10, 15 years to say, are you aware that in the next 10 years, half of your fleet will require this type of services? Again, you know, supporting our local municipality in terms of the infrastructure. It is up to us then to make sure that when we introduce this technology, it is introduced with renewable, and we take it off the grid completely. We've got the PV technology, we've got the wind, we can also introduce battery storage, and the list is long. But the reality is, as engineers, there's no any other person that can provide a solution. It is in our hands. And the issue with Eskom, again, it is up to us to reverse and then improve the picture. And we're not part of the team that will always complain, but unfortunately, due to the responsibilities given to us, it is up to us to then provide a solution. And just a few minutes on the sustainability part. You know, the sustainable developmental goals, high level on the sustainability, what does this mean to us as engineers? One thing that we just need to always remember when we do designs is to the history, the order of things, that some things depend on others. And yes, we are given a mandate. Yes, we are appointed as engineers. Yes, there's a developer. There's timelines that we need to stick to. But if we don't respect the order of things as to who's old between our economy and nature, we'll always have to reverse some of the things. That's why today we've got terms that have been developed by scientists, the greenhouse gas, and these are as a result of pollution emission that was caused by some of the design by scientists and engineers. So it's something that we need to always remember, that nature, human society, and the economy, who comes first? So the economy will have to be guided by the nature, not the other way around. So when we do the design, you will see that if we keep everything in the specific orders, and things seem to flow smooth. Again, while we're talking of sustainability high level, one picture that I've noted, it's actually talking about biomimetics, and mimicking the design features of various creation. I mean, as engineers, you'll agree with me, there's technology that has been with us for years, but we don't want to accept that nature is also teaching us some lessons. We are copying some of the things from our creation. The seagull does not freeze, even when while standing on ice. It has the so-called the counter current heat exchange. The mechanical engineers, you will agree with me. And one of the mechanical and aeronautical engineer, Arthur Fraz, is one of the advocates of this discussion. He actually described this design as one of the world's most effective regenerative heat exchanger. And I mean, your HVAC system, it uses exactly the same technology. And yet nature is right in front of us to teach this lesson. And we've been using this technology. I mean, the seagulls were before us. And so it's something that we always need to consider when we do our designs as engineers. One example again is the boxfish. You know, some of the manufacturers, they've copied the boxfish. There's a car that looks exactly like a boxfish. And even when they look at the specifications, they will tell you that this car is extremely smooth. This car is it's a low drag car that you can hardly hear even when it changes shift the gear from the first to the last gear. And again, it's nature. We're mimicking nature, and it speaks to sustainability. It speaks to what we look at as engineers when we design. So we want to integrate our design philosophy with full understanding of sustainability in our thinking. We want to offer a solution that will actually, when we hand over the technology to the future generation, we are not responsible for some of the mistakes that as engineers today are as a result of our design as engineers today. You know, one member that I would like to quote, Alex Stephen, he mentioned that we only get one shot, and the change takes time, and time is what we don't have. And I'll agree with him that today time is what we don't have, and fail to act boldly enough, we may fail completely if we don't act today. I know as engineers, and you'll agree with me, I mean, I was once a consultant, it's sometimes not easy to fight, especially when a developer tells you that I've got this much budget and this is what I want you to do. But if we don't fight as electrical engineers, system engineers, electronic engineers, mechanical engineers in our built environment space, if we don't fight today, we might not have this space tomorrow. It is not enough that we do our best. Sometimes we have to do what is required. And if we are advocate of change, that's what Winston said. So we want to be advocate of change when it comes to this energy and sustainability space. And surely, how can we show that we advocate of change? That can be endorsed by our design. Our design philosophy will always have, you know, we've got the green building board, we've got the green building design. We'll make sure that the energy efficiency, it's something that's not compromised. The water efficiency, the waste avoidance, the reuse and recycling, it's something that we include as it gets embedded in the solution that we provide to clients. Pollution reduction. And pollution, it's not only air pollution. We look at the noise, the water, the light, even how we design some of the area lighting. It's so shocking that nowadays you still get some of the buildings that, you know, there's uplighters that shine up onto the sky. There's also lights that shine right onto your eyes, and, you know, designs that you know, completed by well-known, respected electrical engineers. And as we embrace the sustainable developmental goals, we also want to make sure that in our design, we show that by embracing some of these energy and sustainability initiatives, by reducing the pollution and the noise, the water, air, even how we look at our lighting design. And if we advocate of change, we'll make sure that where it's practical and possible, we're not going to be working against, you know, our local municipalities. I know with this new building regulation, SANS 10400, and other energy efficiency requirements, it makes life difficult now when you submit your approval, plans for approval, where you've got to prove to our supply authority that we've considered some of these renewable technologies. So as advocate of change, we want to be on the same fence with our supply authority. We want to be on the same change with the initiatives, sustainable developmental goals initiatives, and let the developer be on the other side. And we want to advise him to say, if you've got $1 billion, this is how much we can give you. And if we jump to another engineer, if we speak one language, to say, no, if you've got $1 billion, I cannot endorse your project if you don't introduce renewable technology, if you don't reduce emission, if you don't do 1, 2, 3. And if this is the language that we speak across all engineers, this will make sure that the energy and the sustainability space is managed and sustained efficiently. And high level, you will also remember that there's also commitment globally on the Sustainable Developmental Goals, which is the goals that have been set, and that as South Africans, we also make sure that how we manage our energy space supply, we look after the climate, we make sure that there's affordable and clean energy, we make sure that there's zero harm to our environment. We also make sure that as part of the initiatives that we drive, we want to also create jobs. We also want to create partnership with our society, local community, and improve the skills of the young ones. So this will be also included in how we do some of the designs. You know, maintenance of the PV solar. The skill can be in-house. We can train our in-house young graduates to be, you know, future technicians, to be future masters of these industrial changes that we are experiencing. So again, the point that we like to emphasize is the future is in our hands. The ESCOM load shedding, the energy crisis that we are experiencing, the reduction of emission, the energy security, the clean energy supply, even fighting introduction of renewable energy. As engineers collectively, it is in our hands to fight the battle. And if we advocate of change, we'll collectively win as a team. Thank you. Thank you, Jay. I will hand back to you. And maybe just before I hand back to you, if there are any questions and answers, we will actually take those questions and answers, and we will also be happy to share maybe more detailed response if there's a need to do so. So we might not answer all questions. If there's a need, maybe some of the questions we'll share more detailed response depending on some of the questions. Thank you, Jay and Rob. I'll hand back to you.
Thanks, Shepard. We've got a few questions. The first few is from Sindili Buthelezi. He's asking, as engineers, how can we positively influence the status quo of the energy crisis that the country is faced with? I think you have touched on that in some ways. I don't know if you want to just summarize some of the main points.
Yes, no, thank you, Rob. Surely, as engineers, we can influence and reduce the crisis that we faced. I mean, I've checked not long ago some of the requirements from eThekwini if you're submitting new plans in terms of the energy renewable requirements. It's quite steep, and it's not only eThekwini, and it's actually all other local municipalities that are in support of this discussion. So as electrical engineers, how we can then support this and be advocate of change, it's by collectively making sure that when we present our solution to the developers, we don't make this reduction of CO2 and introduction of renewable technology an option, but we send a proposal presenting it as a must, because it's something that we need. If we don't start with some of the projects that we're currently busy with, we'll never reduce the constraint that our supply authority, including ESCOM network, is experiencing. So that's how we can influence some of the changes and the crisis that we are faced with. And surely we cannot be developers and engineers at the same time, but it calls for us collectively as a team to speak one language, because the mistake that we usually do as engineers is that the developer will go to me and I'll say no, and then he will know that he will go to my friend next door, and my friend next door will say, no, I can give you a design and tell me what you want, I'll make sure that I give you what you want, and we're happy and we go. But if as engineers we speak one language, we embrace the technology that's before us, we make sure that we support the sustainable developmental goals, then we'll take full control of the space.
Right, thanks. And then the next question also from Sindili, do we have the provincial, I presume it's KZN, renewable energy policy?
Yeah, that's quite interesting. I had discussions not only for the South African one, but it was Ireland and some members in Europe, and they were also looking at partnership with South Africans. And I think I will also have a discussion with Sindile off air. But the Department of Energy has got IRP ready, and it's a document that's a master document that we can always use. But in terms of our local one, and it's something that I think it's a good question that Sindile has raised. And again, it is the answer should come from this room. Even some of the discussions that has to do with the future development should be embraced and be managed in a forum like this, where collectively we come together and look for a solution.
Thanks. The next question also from Sindili is, you mentioned solar PV, you also mentioned wind. One of the things he's raised here is hydrogen. Have you got any comments on the use of hydrogen as a renewable source?
Yes, yes. Hydrogen is another solution. Thank you for that question. I see Sindile was firing. And thank you for that, Sindile. Very good questions that you've raised there. Hydrogen is another solution. And I actually didn't want to spend too much time on the mobility side, and I've just high level touched on the electric vehicles. But yes, 100% Sindile, hydrogen is another solution. There's already fleets that do exist, and some of the local municipalities have also introduced, your bus services that uses hydrogen. And we also have, in one of our sites in Joburg, introduced a fuel cell technology that uses hydrogen as a solution. And yes, it is another solution, and it is emission free, and it's a technology that can also be looked at. The only difficulty with either hydrogen as well as electric vehicles is the mileage, in terms of how much mileage can you do. I know with these new electric vehicle trucks, industrial trucks that Volvo is planning to do, they project about 300 kilometers before you charge, before your battery gets low. So again, with hydrogen, I think the technology is new, but there's a lot of development that's taking place in that. And the fuel cell technology, it's also, there's some good results, papers that have been produced. So surely it is a solution combined with other solution, and it is an answer. I agree with you, Sindile.
Thank you. And then the question here from Brian Thompson. Have any wind turbines been installed in the Durban area? And then he also says, could the wind turbines be an issue for bats? Is that an issue?
Yes, there are few wind turbines that are installed around Durban, but they are in a very small scale. I will confirm that the area where this development is really taking a big move is in the PE Kucha area. And but one thing that I can confirm, the bad issue with the design of the turbine and some of the latest developments that's coming into the space, the future development is looking at that and making sure that the birds are protected. And it is a concern that has been raised, but there are few papers that have been also shared with some solution on that. And I can also share this information maybe as part of our response. But yes, it is an issue that was raised, but there's a solution on that. And I mean, looking at areas like your airport, the very same issue that we face with in terms of the beds issue and the turbine that has been raised is the very same challenge that the airports are facing when they land and depart. But there's a solution there. And it's a pity I didn't actually spend a lot of time on the latest papers that have been, journals that have been shared on that topic. But there is a solution on that one. But in terms of the scale, KZN, we're not where we should be in terms of the development. The bigger wind turbine aren't really within our space as yet. It's smaller sizes that I've noted. But we're in a process of looking at introducing this in the near future. And as the project develops, I'm sure maybe in the near future, we'll share some of the findings and the lessons as we develop some of this solution for the KZN. But the simulation was a live simulation for the Durban space.
Thank you, Shepard. Then a sort of three-part question from Richard Artlager. How should the education of engineers be changed? And do you think new graduates are equipped? And then following on to that, what could the SAIE do to assist this?
Thank you, Richard. And yeah, it's a very interesting question. But on the other side, it's a very I don't know how to put it. Timing, I think it's not with us. There's a lot of changes of development that's happening in the engineering space. And the question is between the theory and the actual work that one will face when you get onto the ground. That switch, I think it's where the problem is. The universities are doing a lot of work, I must say, and the new syllabus, I've been involved with some of the universities. They introduce new syllabus. It's in line with some of the changes. But in terms of the development, we had discussion not long ago with other engineers to say the system engineer space, it's actually developing in a very high speed. Some of the electrical engineers, we are forced to be system engineers, like it or not. I mean, if you look at your building management system, if you do building services design, and some of the technologies that we need to introduce as a result of the fourth industrial revolution are more system engineers in nature. So some of the changes that the gap that we need to close with the young graduates, it's for them to understand the theory part in a more practical way. And it's a pity the university cannot do both because they focus more on the academic side. But as engineers in big firms, state-owned enterprises, and consultant and private sector, how we can close the gap is to introduce these graduates, young graduates, engineers in training into the industry as early as some of them when they do their last year at varsity, and let them see exactly all these challenges that we face with. Some of this analysis that they do when they talk of the overload, when they talk of possibility of grid collapse if this and this is not done. It's something that they do, we do in our power system analysis calculation. But if you show them live that if you fail to close this and this and start load shedding, this is what will happen. And if they don't see that practical and live, it will take them 5 to 10 years, depending on where they will be introduced when they start working, before they can grasp and understand and be left to run as engineers without any supervision. But the earlier we start introducing them, some of them before they even get permanent employment, we can easily close the gap to say, these studies that you're currently busy with on your power system, this is how it looks live. This electrical infrastructure that you're currently busy with, this is how it looks when we talk of thermal calculation, when we talk of you know, your voltage drop, when we talk of all these things. This is you know, the result of one underspecking your cable. This is how it looks if it's bent, and it's as a result of the spec being low. So these are some of you know, the contribution as engineers we can do in making sure that we close the gap. Again, also the effort is more from their side. I must say, the biggest mistake that we sometimes do as young graduates, you know, my first month, I want to buy a new car. I want to, you know, start developing in my life. I want a title in my, you know, position. And that's where the mistake is. I think we also need to introduce the engineering training program, where engineers are given the opportunity to be trained as engineers, get a mentor, get a supervisor for a specific duration up until you are left to run a project on your own. And I think that's the mistake. In most companies, what they look for is qualification. Once you do have the qualification, you can shoot straight from varsity to a senior position. And that's the biggest mistake, because you can have the qualification, but lack the experience to look provide a solution. And unfortunately, most of those engineers will learn it the hard way, and some of this hard way will be making mistakes first, maybe a whole city experiencing power cut before one can realize that you know, I was supposed to do 1, 2, 3 before switching on and off that line. And these are some of the contribution as engineers that we can make, bring these young graduates close to us. Thanks, thanks, Rob. I hope I've touched and answered Richard's question.
Thank you, Shepard. Then a question here from Brian Thompson. Where can we find more information on the distributed energy generation potential, the Durban simulation? I don't know if you've got that in a report or paper we could perhaps email or post on the website.
Yeah, it is a study that I was busy with, and I would, yeah, I can share some results on that, high-level results, and I can also share maybe some other sites, papers that can be useful, and because there's a lot of literature review that one had to do, so I can share that info maybe, so that yeah, we can for the KZN area. But I think one other thing that we have as an advantage in South Africa is that some of these solutions might not only be for KZN, it can be a solution for Cape Town as well, even though the weather environment is not exactly the same, but we seem to have favorable conditions across the country in terms of introducing the solution. So some of the papers are not specifically for KZN, but it's a solution that can be applicable in our space in the near future.
Great, thanks. Then there's a question here from Becky Masikani. Isn't there a risk of pushback from the power generators? And yeah, he's talking about Eskom and the Munich, for SEG seen as potential competitor once the Eskom power crisis is over?
Yeah, thanks for that question. I think I'm not sure if I'm in the right space to answer that question, but one thing I can confirm is that due to this power crisis and energy security issues, there's a buy-in now from the government, and the fact that now we're looking at you know, the introduction of this renewable technology. Obviously, how it is introduced, it is managed and controlled. But one obvious thing is that we cannot control demand. Population is growing, and as much as we would like to control the space, but time is against us. So either way, the renewable will have to be introduced. And I mean, we've touched on electric vehicles, we've touched on other technology that's coming into our space. That again increases the demand. And we were talking not long ago about the shipping line. There's now also a demand in terms of reducing the marine emission, where we are now required, not only in South Africa, across the world, to supply power to these vessels. And if you think how many of these vessels we have just in South Africa alone, it's an entire city on its own in terms of the demand per town, per area. So you can see that the demand, it's within our space. So somewhere, somehow, between the government, local municipalities, and private developers, we've got to come into one room and look for a solution. Already the discussions are going towards that, and there's already commitment from the Department of Energy to start opening the tap in terms of the renewable technology, and so it's promising. But as engineers, we can start by introducing this in our design, and that will slowly reduce the demand, because there's nothing stopping us from our own house making sure that we're completely off the grid. That will then reduce the load from Eskom side and from eThekwini side, and that will then mean whatsoever little power that we have will sustain us maybe for the next few years while we're catching up in terms of development.
Great, thanks. And then there's a question from Mohammed Jahan. Considering that KZN's got a large coastline, what about harnessing ocean wave energy for generation, perhaps close to major loads such as eThekwini and Richards Bay? And this may include also current energy, etc., etc. Have you?
Yes, yeah, it is a solution that I must say we've looked at, and there's a possibility, and not only in KZN. I mean, going down Cape Town, I think the Cape Town as well as the East London, PE space. That's where one can harvest or harness more of the wave energy. So it is a solution that can also be considered. And again, you will remember that a solution like that will require partnership not only with the developer, but also with our government, with the authority that looks after the marine side, our local supply authority. And it's a solution that's before us, and it's free energy that's available, because wave energy, it's something that, you know, it's available throughout the day, the night, and I agree with you. And as part of the renewable technology, these are some of the solutions that can be considered as a hybrid. Your wave, your PV, your wind, and with a combination of your battery storage, that can then introduce a solution that will reduce demand from your municipal supply and Eskom supply. And also the other beauty with these technologies that the wave might, in terms of what you harvest from your wave technology versus the wind and the PV, the time is not the same in terms of availability of energy. You might find that PV is during the day, wave might be during the night. You might have more to harvest as well as wind. So if you've got the hybrid that has got all these solutions combined, and affordability is not an issue, a solution is there for one to be completely off the grid, because it means that throughout day and night you will have available energy, and you can also use your battery storage to close the gap.
Thanks, Shepard. Then Basu Chetty just asked if you could touch on the new energy efficiency regulations, any of the main key points.
Yeah, I'm actually not really a specialist on that, but I know the SANS 204 has got quite a lot of information on that, and the SANS SANS 10400, and I think that's the building regulation data guide, the XAX. And in terms of the responsibilities given to the electrical engineers, you can see there that you cannot really provide a solution without proposing a renewable energy. And it also forces one to declare upfront what are your energy initiatives that you are introducing in your new proposal or the solution that you're offering. But over and above that, the ISO 5100, it's the key document that governs everything. It's the best practice. So if we want to look at the energy management system. It has got a solution from start to the end in terms of how one can set your targets, how one can set your boundaries, and how do you even measure and verify the energy usage. How do you even declare your significant energy users, and how do you even look at your drivers, and what are the drivers that influence your energy performance. So these are some of the documents that we can always make reference to in the energy efficient space. And the best practice ISO 1 it has been tested globally, and it's one document that can be a guide when one wants to put an energy plan, because that's critical. Without an energy plan, one cannot set energy targets, you cannot set your boundaries, you cannot manage if you don't even know where are your boundaries. So that the document has got all that, but you will see also when you go through the ISO 5100, it also make reference to some of these documents that I've touched on if you're looking at the South African environment space. So these are some of the standards and regulatory requirements that can guide us in the space.
Thanks, Shepard. Then just two comments really from Richard. He says we can't really have growth without excess power, and we need to bear in mind that we have to decommission older power stations, and then growing economies are energy intensive. For example, a data center can take 10 to the 20 megawatts. I think it's just highlighting the need for electrical energy going into the future. I don't know if you've got a comment on that.
No, I fully agree with Richard, and we remember also that we still have old plants that we still need to get them off the system, and we're battling also to get the new plants in. But some of the discussions, ESCOM discussions that are set in a while ago, where they were talking about new corridors to be introduced, and some of these new corridors we're also going to embrace the renewable technology. So I fully agree with Richard that we need to start working on that. And we can't talk about a solution when we still haven't decommissioned the old plant. And remember, there's a reason why a system is designed for a specific number of years. And if we say it has reached its design life spec, it has to be decommissioned, and we cannot keep on claiming that we've got spare capacity when we are still banking or relying on a solution that, on a plant that was supposed to be decommissioned 20 years ago. So I think Richard is spot on there, and it is something that we need to, as a country, work on and make sure that we start declaring what we have after we've decommissioned old plants that aren't supposed to be in the grid.
Great, thanks, Shepard. That's the end of the questions that I have, and I'd like to hand back to Jay.
Thank you, Rob.
Are you there, Jay?
Yeah. Okay. All right. Okay. And yeah, thanks, Shepard. Thanks for that. It was a great presentation, explaining the difference or explaining it all: energy, the ability to do work, and more especially as far as electricity is concerned, and then the sustainability part, where we need to meet the current needs without compromising the future. And there you talk about the transition from the fossil fuels to the renewables. It's an all-encompassing field, and there is a lot that we can learn. And as you rightfully say, learn from nature. You can't go wrong. Thanks, Shepard. It was a great presentation. And we sometimes need to be reminded that some things that might seem so obvious are not so obvious. We need to give it some thought. Thanks to the Thanks to the South African Institute of Electrical Engineers for providing a medium for professionals to share knowledge, experience, and expertise. Thank you for attending today's session. Please visit the SAIEE website on www.saieor.org.za for upcoming events. I would also like to take this opportunity to encourage non-members to become members. There is much to benefit from the organization. Take care and be safe. Thank you for attending.
Thank you.